Problem 12, the number of bacteria, n, in a dish after t minutes is given by this equation. Find the value of n when t is 0. Okay, so we're going to plug in 0 for t, so 800 times e to the 0.13 times 0. Notice I'm doing the substitution. I'm setting up everything. I'm showing all my work. Really important. Okay, this is 2 points, so you can't just write down the answer. You got to show how did you set it up. So my next step would be 800 times e to the 0 times 0.13 is 0. E to the 0 is just 1, so n is equal to 800 times 1. N is equal to 800. Find the rate at which n is increasing when t is 15. Okay, increasing, rate of increase. That sounds like rate of change. So that would be slope. So that means I need to find n prime. I need to find the derivative of n. So I always keep my constant, 800. Now I need to take the derivative of e to the 0.13t. So that would be e to the 0.13t times the derivative of the exponent. The derivative of the exponent is 0.13. So here's my derivative. Now I want to find that to the 15th. I want to plug in 15 for t. Oh, this is a calculator problem. I was just thinking, oh my gosh, I don't want to do this without a calculator. We are going to pull out a calculator for this. 0.13 times e to the 0.13 times 15, because we want it at when t is 15. Grab my calculator. And I'm going to put in 800 times 0.13 times e to the 0.13 times 15, and I get 731. So that would be, find the rate, would be the rate of increase is 731. What are my units? Bacteria per minute. Okay. After k minutes, the rate of increase in n is greater than 10,000 bacteria per minute. Find the least value of k. So at k minutes, the rate, okay, so again, I'm talking about the rate, so I'm going to be using the first derivative. So at k minutes, so instead of t, I'm going to put in k. So I'm going to have 800 times 0.13 times e to the 0.13 times k instead of t. It says it's greater than 10,000. Find the least value for k. So I need to solve for k. So if I multiply these together, I get 104 e to the 0.13k. I did that on my calculator, by the way. Is greater than 10,000. Then I'm going to divide both sides by 104. And I get e to the 0.13k is greater than, let's see, what is that? Let's go ahead and do that on the calculator. Oh, sorry, I have a cold. Let's see, let me just double check. 800 times 0.13 is 104. Okay, 10,000 divided by 104 is 96.15384. I want to keep all my digits until the very end. Okay, keep them all. Keep them in your calculator. It's the easiest way to do it. Okay, now notice my variable is in the exponent. So to get that out, I want to change the form from exponential to logarithmic. Since the base is e, I'm going to change it to natural log. So natural log base e of 96, 96, because my decimal is one place, 96 point, I'm going to go ahead and just round it off for writing it down purposes, but I am going to keep this in my calculator, is equal to k. I'm changing it to equal to for the minute, and then I'll change it back to well, anyway, I'll do the last step later in a second. But let's just figure out what would K be equal to, and then we're going to change it back to answer the question. All right, so if I want to do this, I just have to put this into my calculator. Oh, sorry, I wrote this down wrong. It's equal to 0.13, okay? To get the K by itself, I'm going to divide both sides by 0.13, 0.13. So put this into my calculator. So I've got natural log of 96.2, close my parentheses, divided by 0.13, gives me 35.12. So it says find the least value of K. So the least value of K, where K is a member of Z. Z, oops, can't see that. Z means integers, okay? So K has to be a whole number, can't be a decimal. So what's the least amount of time? The least amount of time is going to be 36 minutes, because notice it takes more than 35 minutes to get to 10,000. So the least amount of time, I couldn't put 35. I can't round it off to 35 because it won't be at 10,000 yet. So I have to say 36. So the answer is going to be, we can say this, K equals 35.1. But the answer, find the least value of K, is going to be 36 minutes, because we will not have 10,000 at 35 minutes. We'll be under 10,000 at 35 minutes. So you can't round this down because we have to have at least 10,000. We need to be greater than 10,000 bacteria. So the answer is actually 36 minutes. Now I'm going to go blow my nose.